Well, here we go with the last lesson of the semester, lesson 40, section 11.3, and this will be our one and only discussion on hyperbolas. Hyperbola is quite simply the collection of points in a plane, the difference of whose distances from two fixed points in the plane is a positive constant. And so we have a transverse axis here, and I'll talk about this a little later, and we'll either have a horizontal transverse axis or a vertical transverse axis. Again, the hyperbola is a set of all points in the plane, the difference of whose distances from two fixed points in the plane is a constant. So here I have my two foci marked. I have point B and point P. And again, those distances, the difference of those distances is always going to be the same value. And that's not something you really have to know too much about. So the midpoint of the two foci is the center of the hyperbola. And again, the focus is still C units from the center, just as it was um, in our ellipses, in our discussion on ellipses. And again, horizontal transverse axis and vertical transverse axis. And I'm kind of introducing that ahead of myself here a little bit. And the point where the hyperbola intersects the line joining the foci are the vertices. And those are still A units from the center. Now the difference here is, though, A is smaller than C. Notice the foci are farther from the center than the vertices. So the line segment connecting the vertices is the transverse axis. The foci lie beyond the transverse axis. The other axis is called the conjugate axis, and its endpoints are W and W prime. And they're not points on the hyperbola. However, they're really important in creating the auxiliary rectangle that will assist in sketching the graph. And so again, A units from the center is the foci, or to the vertices, excuse me. B units from the center is to the endpoint of the conjugate axis, that's the other axis. And A can be bigger than B, B can be bigger than A, or A and B can be equivalent to each other. The deal here is that C will be the biggest of the three. So I have a transverse axis, and I also have a horizontal transverse axis, and I also have a vertical transverse axis here. And we're going to use this auxiliary rectangle to set the asymptotes, and I'm just going to clue you in on that, and I'll talk more about that here in a second. Here's the basic equation of the hyperbola with its center at the origin. Very similar to what we had in ellipses, the only difference is the minus sign. Also, the a squared always comes first, whether you have the x squared first or the y squared first. I will say this. When the x squared is positive, we have a horizontal transverse axis. When the y squared is first, we have a vertical transverse axis. A is always the first denominator, regardless of whether it's bigger or smaller than b. Notice that A can be bigger than B, or B can be bigger than A, or they can be equivalent. The length of the transverse axis is 2A, the length of the conjugate axis is 2B, and the foci are C distance from the origin. Notice a little change in our equation here. C squared is equal to A squared plus B squared, because now C is the biggest of the three, and they're always positive. And when we move the center to h comma k, it's going to be x minus h and y minus k, regardless of which one comes first. Again, if the x comes first, then the vertices are going to be right to left, and you're going to have a right branch and a left branch. If the y comes first, the vertices are going to be up and down, vertical from each other, and you're going to have an upper branch and a lower branch. So these asymptotes, we're going to draw this auxiliary rectangle. We're going to use the vertices and the endpoints of the conjugate axis to serve as the midpoints of this auxiliary rectangle. We're going to extend its diagonals, and those will be the asymptotes. Those will be our guides. And the slopes of those asymptotes are going to be plus or minus a over b, or plus or minus b over a, depending on which one comes first, the x or the y. And I don't try to memorize that. I'm going to show you this in a second. Well, I'm going to show it to you right now. So if the x comes first, then the equation for this asymptote is going to be, or the slope actually for the asymptote is going to be plus or minus b over a. And again, slope is always change in y over the change in x. And underneath the y, I see a b, and underneath the x, I see an a. Well, what happens if the y comes first? Well, then the slope is going to be plus or minus a over b. I don't try to memorize a over b or b over a. Slope is always the change in y over the change in x. So regardless of who comes first, I look underneath the y, I see an a, or I look under the y and I see a b. I don't care. It's y over b, or y over x. Oh, enough talk. Let's do some examples. So here's we got y squared over 49 minus x squared over 16 equals 1. It's the basic formula for a hyperbola because we got a minus sign. The y comes first, so my vertices are going to be up and down. We're going to have an upper branch and a lower branch. So my a squared is 49 and my b squared is 16. Not because 49 is bigger, it's because it's underneath the positive term, the y squared. C squared is the sum of 49 and 16, which is 65. So A is 7, B is 4, and C is the square root of 65. So my vertices are going to be 7 units from the center. The endpoints of my conjugate axis will be 4 units from the center. And my foci will be the square root of 65 units from the center. Since the center is at the origin, I'm going to go up and down to find my vertices. So 0 plus or minus 7 is my vertices. The foci are going to be on the same axis or the extension of that axis. 0 plus or minus square root of 65. The endpoints of my conjugate axis are going to be plus or minus 4 is 0. Slope of the asymptotes is going to be the change in y over the change in x. When I look underneath the y, I see a 7. And when I look under the x, I see a 4. So the slope of my asymptotes is going to be plus or minus 7/4. So I go ahead and plot this. I put the vertices in there at plus or minus 0 plus or minus 7. And then square root of 65 is 8 point something. So I put that in there. 0 plus or minus square root of 65. I dot in my auxiliary rectangle, going through the vertices and going through the endpoints of the conjugate axis. And then I extend those diagonals. And those extension of those diagonals becomes the asymptotes. So now I can sketch in the hyperbola. And the slope is up 7 over 4, and you expect that because, again, 7 is underneath the y, 4 is underneath the x, and I just swoop in, go through the vertices and swoop out, and I do that on top and bottom. And the reason I had an upper and lower branch is because the y came first. So I knew I was going to have my vertices going up and down. Let's do some more examples. So here we have x squared over 4 minus y squared over 25 equals 1. My a squared is 4, my b squared is 25 because the 4 is under the positive term. And so my vertices are, now again, the x came first, it's positive, so my vertices are going to be right to left from the center. So my vertices are plus or minus 2, 0, because a is 4, so a squared is 4, so a is 2. My b squared is 25, so b is 5. I'm going to go up and down 5 units to find the endpoints of my conjugate axis. C squared is 4 plus 25, so that's 29, so C is square root of 29, and that is beyond the vertices, so I'm going to go plus or minus square root of 29 over 0. Now to find the slope of my asymptotes, I go under the y, I see a 5, I go under the x, I see a 2. I don't care about a over b's or b's over a's. So my slope of my asymptotes is going to be plus or minus 5/2, and therefore the equation of my asymptote is going to be plus or minus 5/2 x, because it's really mx plus b form, but they both go through the origin, so that's why. So let's sketch this out and take a look at it. So I'll go ahead and put the vertices in there at plus or minus 2, 0. I put the endpoints of the conjugate axis at 0 plus or minus 5. I dot in my auxiliary rectangle. I extend the diagonals. Those are the equation plus or minus 5/2 x. And now I'm ready to sketch. And so just make sure you go through the vertices. And the vertices are on the x-axis, so I use those asymptotes as my guide. I swoop in, go through the vertices, and swoop out on both sides, right and left branch. The equation of my asymptotes is y equals plus or minus 5/2 x, because they both go through the origin, so my b is 0. More examples. Well, here I have to do a little work to get this into standard form first, so we're going to divide both sides by 4 and see what this looks like. So we divide by 4, we end up with y squared over 1 minus x squared over 4 equal 1. So my a squared is 1, my b squared is 4, and because the y squared is positive, I'm going to have a transverse axis going vertical. So from the center, I'm going to be going up and down 1 unit to get to my vertices. So a squared is 1, so a is 1, b squared is 4, b is 2, and c squared is 1 plus 4, which is 5, so c is 5. Because the y came first, I'm going to go up and down from the center, the origin, and my vertices will be at 0 plus or minus 1. And I'll go up and down c units to find the foci, 0 plus or minus square root of 5. And the endpoints of my conjugate axis will be right to left then, plus or minus 2, 0. Now again, the slope of my asymptotes will be plus or minus 1 over 2, 1/2, and therefore the equation is going to be plus or minus 1/2 x, because again, plus b, the b is going to be 0 in this case. Let's sketch it out and take a look. So I put in the vertices at 0, plus or minus 1. I put in the endpoints of the conjugate axis at plus or minus 2, 0. I sketch in my auxiliary rectangle, and I extend the diagonals. And you notice those have a slope of up 1 over 2. So using those asymptotes as my guide, I swoop in, go through the vertices, and swoop out. And I have an upper and a lower branch. And I knew I was going to have an upper and lower branch as soon as I saw the y squared was the positive term. Got it. Well, we can't leave the center at the origin, can we? We have to move it to hk, so this is going to be x minus h and y minus k. The asymptotes then will still look for the slope, and then we're going to use that center point as the common point. And here's basically the same thing. The only difference is the y comes first, so it's y minus k, and again x minus h. Not a whole lot's changed here. We're still going to use that center point, hk, the center of the hyperbola, as our common point in our point slope form to find the asymptote equations. And I'll show you some examples here. So we've got x minus 2 squared over 16 minus y plus 3 squared over 25 equals 1. So our center is going to be, and now careful here, in this case the x came first, but always find the x first. Our center is going to be at 2, negative 3, so everything's going to come off of the center. So the a squared is 16, the b squared is 25, and the c squared is 41. So a is 4, b is 5, and c is square root of 41. So the vertices are going to be right and left of the center because the x came first. So I have a transverse axis that is horizontal. Well, it's from the center point, and when you move right and left, you mess with the x. So my vertices are going to be at 6, negative 3, and negative 2, negative 3. To find the foci, we're going to add that c to the x value of the center, so 2 plus or minus square root of 41, common negative 3. To find the endpoints of the conjugate axis, we're going to go up and down, so you mess with the y from the center. So 2 common negative 3 plus or minus 5 yields 2, 2, and 2, negative 8. And now for the equation of the asymptote. Well, again, you go under the y, I see a 5. You go under the x, I see a 4. So the slope of my asymptote is going to be plus or minus 5/4. And so the point they have in common is the center. So I'm going to say y minus a minus 3 equals plus or minus 5/4 x minus 2. And really, those come, if you look, you can look up in the original equation, you'll see that. All right, let's wrap this up. So we go ahead and sketch everything, and I put in my auxiliary rectangle by going through the vertices and the endpoints of the conjugate axis. And again, I'm marking these off from the center. I extend those diagonals, and then I'm going to use those as my guides as I swoop in and swoop out. All right, use those asymptotes as your guides, and just make sure you go through the vertices. Now notice we solved the equation for the asymptotes for y, and so I had y plus 3, so I simply subtracted 3 from both sides and ended up with y equal plus or minus 5/4 x minus 2 minus 3. And that's how we wrap up the asymptotes there. All right, moving on. Well, here's the expanded form of the equation of the hyperbola, and we're going to complete the x with the y and complete the x with the x, and we'll get this into standard form. All right, let's get it organized. Let's put the y's together and put the x's together. So I put the 4y squared plus 40y minus x squared minus 4x equals negative 60. Drag the 60 to the other side. I factor a 4 out of the y terms, and I factor a negative 1 out of the x terms. So I have 4 times the quantity y squared plus 10y plus leave some room minus x squared plus 4x plus leave some room. Half of 10 is 5. 5 squared is 25. But you have to add 100 to both sides because you have to multiply it by the 4. Half of 4 is 2. 2 squared is 4, but there's a negative out in front of that parenthesis, so you have to subtract 4 from both sides. So that's going to be 4 y plus 5 squared minus x plus 2 squared equals 36. Divide both sides by 36, and you get y plus 5 squared over 9 minus x plus 2 squared over 36 equals 1. And so we've got it into standard position. Now, we could probably figure out what the center of this thing is, and we could get the a squared and the b squared, and we could work some things out, but I need to move on. Let's find the standard form of the equation of the hyperbola given the vertices and the foci. So what are we giving you here? We're giving you A, and we're giving you C, and you need to find B, and then we can do this. So A is 4, C is 6, so A squared is 16, and C squared is 36, so the A squared is out of the way. And because the vertices are on the y-axis, I know it's going to be y squared over A squared minus x squared over B squared equals 1, and the vertices are on the y-axis. So C squared equals A squared plus B squared, so 36 equals 16 plus B squared, and B squared is 20, and that's all I need. It's y squared over 16 minus x squared over 20 equals 1. We've got it in standard form. And again, the y squared came first, and the A squared went underneath the y squared because the vertices were on the y-axis. Well, now we need to do a little work. We're giving you the vertices, negative 2, negative 3, negative 2, 5, and the foci, negative 2, 8, and negative 2, negative 6. You need to find the center. We've got to find A, we're going to find C, and from that we can find B, and we can knock this out. I suggest you sketch it out. Well, you know the center is halfway between the vertices or halfway between the foci for all that matters. So I went ahead and sketched this out at negative 2, negative 3, negative 2, 5, and I need to figure out what is halfway between those two. And it's 8 units from negative 3 to 5, so it must be 4 units from the vertices to the center. Therefore, the center is at negative 2, 1. It's halfway between the vertices, or you can say it's halfway between the foci. So I know that my vertices are up and down, so that means y squared is going to come first. And it's going to be y minus 1 squared over something minus x minus a minus 2 quantity squared over something equals 1. So I've got that figured out. I need to figure out what A and what C is. From there I can find B. Well, it's 4 units from the center to the vertice, and it's 7 units from the center to the foci. So A is 4, and C is 7, so A squared is 16, and C squared is 49, and C squared equals A squared plus B squared. So 49 equals 16 plus B squared, and that means B squared is 33. And so B is the square root of 33, which, the endpoints of the conjugate axis are a little tough to find here. So I'm not going to be too concerned that you get that exactly right. But I go ahead and dot all that in, and I mark right and left from the center to get the endpoints of my conjugate axis. I go up and down from the center to get the vertices, which I already had marked, and I dot in my auxiliary rectangle, and I extend the diagonals, and that gives me my guides to sketch this out. And I swoop in, and I go through the vertices, and I swoop out. We have an upper branch and a lower branch. And now for the equation of this thing, it's going to be y minus 1 squared over 16 minus x minus a minus 2 squared over 33 equals 1. I put in the a squared, and I put in the b squared. And again, because the vertices were up and down, I know the y comes first, and it's positive, and gets the a squared, and the x comes second, it's negative, and gets the b squared. Moving on. All right, find the equation of the hyperbola. Here's the vertices, and there's passing through a point. So we know it's going to be y squared first, and we know that a is 6, and that means a squared is going to be 36. What we don't know is the b squared. So we're going to write what we know, and then plug in the 3 for the x, the 9 for the y, and solve it. So a is 6, a squared is 36. It's y squared over 36 minus x squared over b squared equals 1. And again, the vertices were up and down, so that was on the y-axis. So the y squared came first, and the a squared went underneath that one. I'm going to put 3 in for x. Careful, make sure it goes in for x. I'm going to put 9 in for y, and I'm going to solve for b squared. And we just need to do some math here. Put the 9 in for the x, the 9 in for the y, and the 3 in for the x. You get 81 over 36 minus 9 over b squared equals 1. And I do some math, and I come out with b squared equaling 36 over 5. And again, you can fall through with that and slow this down or stop it and look at what we did here. But basically, I just did math, and there's more than one way to solve this, but this is the way I chose to do it. So what are you going to do with that 36 over 5, though? Well, that's your b squared. So I've got y squared over 36 minus x squared over 36 fifths equal 1. But we don't like leaving fractions inside of fractions. So the final answer that I would have on my exams is y squared over 36 minus, and then multiply by the reciprocal of the denominator, 5x squared over 36 equals 1. And that's how I would walk away from this one. Let's do some more. Well, here we're giving you the vertices and we're giving you the equation of the asymptote. So we're giving you A, which is 4, so A squared is 16. And the vertices are on the x-axis, which tells me x squared is going to come first, and the 16 is going to go underneath there. And then I've got to figure out if that 3 over 2 is A over B or B over A. And I think I know how to figure that out. So because it's x squared first, I have A squared underneath the x squared. And that means that this asymptote is going to be B over A. Because again, underneath the y I see a B, and underneath the x I see an A. And so my slope is going to be plus or minus B over A. So that is equal to 3 over 2. And I already know A is 4. So I'm going to be able to plug 4 in for A. And from here, I'm going to be able to solve for B. And I'm going to pretty much have this one done. And again, the reason I know this is going to be B over A is because look at the equation. The vertices were on the x-axis. So this is x squared over A squared minus y squared over B squared. So underneath the y, I see a B. Underneath the x, I see an A. So 3 halves equals B over 4. Cross multiply, and B is 6. So my A is 4, my B is 6. Therefore, my A squared is 16, and my B squared is 36. And we're done. X squared over 16 minus y squared over 36 equals 1. Again, set the equation up and figure out if it's A over B or B over A. Let's do another one. So here the y-intercepts are at plus or minus 7, and the asymptotes are at y equal plus or minus 4 over 1x. And I might also add here that the center of the hyperbola is at the origin. So the y-intercepts are plus or minus 7, so that's a funny way of saying that the vertices are at 0 plus or minus 7. So A is 7. It's y squared over A squared minus x squared over B squared equals 1. So my asymptotes are going to be in the form of plus or minus A over B, because underneath the y I see an A, and underneath the x I see a B. And so since my A is 7, I'm going to set 4 over 1 equal to 7 over B. Cross multiply, and B comes out to be 7/4. So A is 7, and B is 7/4. Just got to square them, and I'm done. So A squared will be 49, B squared will be 49/16. So this is y squared over 49 minus x squared over the fraction 49/16. We don't like that though. So the final answer is there in blue. Y squared over 49 minus 16x squared over 49 equals 1. There you go. So you determine whether it's going to be B over A or A over B after you determine whether the vertices are going to be horizontal or whether the vertices are going to be vertical. All right, let's wrap up our last problem here. We have a horizontal transverse axis. That means right to left is going to contain the vertices, and a conjugate axis that must be going up and down. And so we're telling you right now that 2a is 18 and 2b is 20. So 2a equals 18, so a is 9, and a squared is 81. 2b is 20, so b is 10, and b squared is 100. Now the reason I know it's going to be x squared over a squared is because it said horizontal transverse axis. Transverse axis connects the vertices. So that's right to left, which means my x squared will be positive, and the a squared will be underneath the x squared. So I move the a squared underneath the x squared and the b squared underneath the y squared. I get x squared over 81 minus y squared over 100 is equal to 1. And that wraps it up. Well, this concludes lesson 40, and this concludes Math 154. Well, we still have a final exam. So get to work on the homework. Oh, okay, we still have one more homework, so I guess Math 154 is not over with yet. You still have some work to do. Get busy.